Hello?
Hello.
Yeah, I can hear you. Let's wait. I can see your screen, Karthik, and wait a minute.
Yeah,
Is ready not came?
yeah,
Ready
yeah.
pin caller. Yeah.
Hello.
Hi, ready. This is Karthik, Hadoop trainer.
Okay, okay.
Hi,
Hi, hi,
hi. How
Karthik.
are you? Hi.
Good, good, good. How about you, sir?
So, so myself is Karthik. I have overall 6 years of IT experience. So I worked for 3 years in Java side. Then after 3 years, I worked on Hadoop side. So currently, I'm
Okay.
working in HP. So can you explain about yourself, please?
Yeah, yeah. Actually, I got 9 years of experience on storage and Unix.
Great.
So mostly I worked on console and NetApp. So
Okay.
I worked in multiple MNCs. Like I worked for Dow Jones as a
Okay.
RPS SQL developer, Oracle developer. And then
Okay.
later I came to India and I worked for Emphasis, where I worked as a
Okay.
Unix administrator. And then I worked in the IBM for 5 years, where I
Okay.
worked on the console and NetApp. And later I got opportunity in United Health Group. So I worked for United Health Group as a NetApp administrator. Right
Great.
now, recently I came to US like some past 1.5 months. And most I'm searching for a job on NetApp.
Okay.
The cost is very, very low and yeah, looking for a job right now. So my friend suggested to go for Hadoop. So that's why I want to learn Hadoop admin
Oh,
side because
okay. Admin.
until now, yeah, almost
Yeah.
9 years I work as an admin only. I never get any chance like developing. So developing core means it's a big task for me.
Yeah,
So that's
actually,
why.
you have to develop the scripts. You have to know the. I have to have an idea on Java, MySQL, as well as like just Hive, like basics. You have to know for development. For admin means like there'll be two parts in Hadoop. First one is admin, and next one is development. So admin means it will be regarding the installation part. After whatever the installation is done, if you want to create any scripts, we'll be using developments. We'll be using MySQL as well as Java there.
Okay, okay. Yeah, I'm good at SQL too. I know basic on SQL also. So because
Okay.
I
Yeah,
worked
yeah.
on
Speak.
SQL also, so I know SQL too.
So today I'll give you a basic demo and I'll share you the course content of Hadoop admin. Okay.
Okay, okay. Because here, like, let me tell you one thing. The requirements are like not only on admin. If you get a job, like any requirement for admin part, they look for developing part also. Okay,
So
like not because
you want to learn development also?
not like that, but interview perspective view, at least I need to answer something, right?
Okay,
If
okay, I'll be providing you the what are the questions they'll be asking you in interview for development also. Like so
yeah,
installation
yeah.
part I will cover and what are the basics for the like development also I will cover. Okay.
Okay, yeah. Right, right.
So can you ping me your email ID so that after the class I will be sending you the course content?
Mm-hmm. Okay, give me.
One second. Reddy at 4 at gmail.com.
Code ready for you at the rate of gmail.com.
Yeah, one second. I'll save it. Yeah, can it? So today I'll give you a short demo so you can understand what is meant by Hadoop, where to use Hadoop. Okay,
Yeah.
can you start?
Yeah, Karthik, right?
Yeah, yeah, Karthik.
Yeah, I'm looking for, uh, admin, Hadoop admin. I want to become as a specialist in Hadoop admin in
Yeah, yeah,
future. So
Yeah.
I need that not that much of training. I'm expecting from you.
Yeah, I can teach you very nice admin. So the like first I'll be explaining the basics of Hadoop. Then we'll be going to map reduce part because you have to have an idea on map reduce part that is required for admin. Then after we'll be using how to schedule the jobs using Uzi. Then next one is installation, how to install the different modules in Hadoop. Okay, and how to
Okay.
format cluster mode of sudo. That is mainly regarding the Hadoop admin. It will take around 45 days. Okay.
Okay. Okay.
So and I'll give you
So
a
you
basic idea on
and
Hadoop development concepts. Okay.
okay. Okay. And one more thing, Karthik. Like,
Yeah.
I am only one in the class, right? So can you cover it as soon as possible, if you don't mind?
Yeah,
Like,
yeah, sure.
uh,
I'll cover. First 1 week, like you have to understand the basics. After that, I'll make it fast. Okay.
okay, okay. Like you said, like 45 days, right? So that's why I'm looking for
So I'll
want
make
to
I'll
complete.
make it by 30 days. 30 days. Okay.
Okay, fine, fine.
So daily 2 hours, 1.5 hours. I'll cover like it. Okay.
Yeah, problem, not a problem for me.
So, so generally, what do you mean by big data? Huge amount of data that may be a structured, unstructured, and semi-structured data that cannot be processed using RDBMS. That is known as a big data. So, example of structured data is comma separated, pipe separated, or any data that is in a structured format with any delimiter. Unstructured data means video files and audio files. Semi-structured data will be coming to know that is XML data, JSON data, and text data. If there is a huge amount of data that may be structured, unstructured, and semi-structured, if that cannot be processed using RDBMS, then it is known as a big data. To process that huge amount of data, we will be using a framework known as Hadoop. Okay. What are the different RDBMS tools available before Hadoop to store the data? Generally,
What
before
what
using the
what do
yeah,
you
yeah
what do you mean by RDBMS? Regional database
resi-
management,
residual
something I don't.
database management systems like MySQL, Oracle, Teradata. Because before introduction of Hadoop, the data will be if the input data is in the form of semi-structured and unstructured data, they will convert into structured data and store in these RDBMS tools. Because previously the in IT the data can be stored only in the structured format by using this database. Now we can store any type of data like unstructured, semi-structured, and structured in Hadoop. Okay, before introduction of Hadoop, in that structured data is stored in these databases like MySQL database, Oracle database, and Teradata. These are the different databases. Okay, for data
Oh,
storage. So what are the main drawbacks of RDBMS? Why we are moving to Hadoop? Storage is one of the main drawback. If the data is up to TBs, we can store the data in MySQL or Oracle or like Teradata database. If the data is like zettabytes, because in future the population is increasing and the data is also increasing. If the future is of if the what you say, the data is in zettabytes to petabytes, the normal RDBMS can't store that much amount of data. So in order to store that much amount of data, we'll be moving to Hadoop framework. And one more disadvantage is the RDBMS can process only structured data. It can't process unstructured and semi-structured data. Okay. Even though if we store terabytes of data in the RDBMS, if we try to retrieve them at a single instance, it is not possible using normal RDBMS. Okay. That's why we are going to Hadoop framework. And one more thing is, consider your name is some Ram. So currently you are in Bangalore. Now you got an offer in Hyderabad. Now you moved to Hyderabad. Next you got an offer in Mumbai. Next you move to Mumbai. So the last updated value Mumbai will be present if you store the data in RDBMS. But in Hadoop, the last three updated values, like first Hyderabad, next Bangalore, next Mumbai. The last three updated values you can keep in Hadoop. Okay. This is main advantage of Hadoop. Whereas in MySQL, the last updated value will be present. So to
okay.
overcome all these disadvantages, we'll be using Hadoop framework. So storage, there is no problem for storage because we'll be using a multiple systems of low commodity hardware in Hadoop. So there will be no problem. They will be having huge amount of RAM and huge amount of hard disk. We'll be having using many servers. So what are the advantages of Hadoop? It can process structured data, unstructured data, and semi-structured data. And one more thing is, it is an open source. It is a freeware. It is belongs to Apache Software Foundation. If you go to the Apache website, you can download easily. Okay. So one more thing is, it can process terabytes of data. Suppose if you want to store the data into the Hadoop framework, we can store easily and we can retrieve the terabytes of data very easily at high speeds. Okay, this is one of the advantage. And the hardware used, like we want to store the data, we will be using here servers. The servers or system, we can say, where we can use a cheap and commodity hardware, because whereas in RDBMS we'll be using high cost hardware systems, because suppose if you want to store some structured data into the RDBMS, where we'll be having only single copy. So if that machine fails, entire data will be lost. But in Hadoop, we'll be having a single file in 3 different systems. Even if one system fails, we'll have a same data in other 2 systems. Okay. So here the hardware we required is cheap and commodity hardware, means the normal, not of high cost and not of medium cost. It is of commodity cost, means cheap cost, means normal cost, moderate cost, so that even if one system fails, the same data will be available in another system. Because by default, if we store a file in Hadoop file system, the data will be replicated 3 times, means the data will be stored in 3 different systems. Suppose if I store a file sample.csv in one Hadoop system, the same copy will be duplicated in remaining systems also, because if one system fails, we'll have the data in other systems. So it will be like safety data. Data is replicated. Even if one system fails, we can access the data from another systems. Okay.
Cluster, right?
Yeah, it's like a cluster. We'll be having a
Okay.
cluster. The cluster and all I'll explain in coming slides. Okay.
Okay. So if one system
Yeah.
fails, the other 2 systems are available.
Yeah.
So now, are we going to recover the third one also later?
Are you going to?
Are we going to recover the third one, whatever the fail?
So you are
Like
not audible.
you said three places, right?
Yeah. Yeah.
The data is going to store in 3 places. If one
Yeah.
if one site totally failed, means how I need to tell you. Yeah, if one place got crashed, the other 2 places are available. So there is
Yeah.
no outage for the customer. So what
Yeah.
about the third site? So are we going to recover or backup anything?
Yeah. So what will be doing then? Then at that time the Hadoop admin will keep the cluster in safe mode, and he will try to make the modifications to the damaged system, or he will remove the damaged system and he will try to install a new node or new server. Okay.
Okay.
That and all we'll learn in next coming slides. Okay.
Okay.
So about the 90% of the world's data is generated the last 2 years. Because why? What is the main reason? Due to the increase in technology. Because there is crores of population throughout the world, everyone is using the internet. That is due to the increase in technology, increase in the internet usage, decrease in the storage costs, increase in the online shopping, and increase in the online banking. Because everyone is making transactions like Snapdeal, Flipkart, customers are making through online only. There is online shopping and online banking. Next, decrease in storage cost, because nowadays we can get a CPU with monitor with around 10,000. Okay, the laptop around like 30K. So due to the decrease in the storage cost, everyone is using this internet and laptop. So due to it, the huge amount of data is like generated. Suppose consider a person is maintaining 3 to 4 Gmail account. Like there are crores of people throughout the world. So the crores of people are maintaining almost the crores of mail accounts. So when he try to open one mail account, one log file is generated. So even if one person is maintaining 5 mails, means almost 5 logs are generated at a time. Like crores of people, means the crores of log files are generated. All these log files are coming under semi-structured or unstructured data. So we have to process all this semi-structured and unstructured data and convert to structured data, so that the company or Gmail will be knowing that the mail which we may be a Yahoo or Google, depending upon the mail used by the customer. So they will be knowing that what are the features customer is using and what are the features they are not using. So they will process them into structured data, so that in future versions of their mail they will modify the features which are used by the customer, and what are the features which are not used by customer they try to eliminate it. So all these log files will be like a data. To analyze this data, this unstructured and semi-structured data, it is not possible using RDBMS, because RDBMS process only structured data. To analyze this unstructured and semi-structured data, we'll be using Hadoop framework. So Hadoop is involves two modes. First one is data storage and next one is data analysis. For data storage, we'll be using Hadoop distributed file system, and for data analysis, we'll be using MapReduce, Pig and Hive. So what is this data storage and what is this data analysis? So Hadoop is a framework where we can store the data. Whatever the data we store, we can retrieve the data. So for data storage, we'll be using Hadoop distributed file system. We'll be saying it as HDFS. Whatever the data we store in a file system, if you want to analyze the data, we'll be using MapReduce. That is, MapReduce is based on the Java. Okay. Next, we'll be using, this is the first generation is MapReduce. Using MapReduce, we can analyze the data. The second generation tools are Pig and Hive. The Pig and Hive are the tools on the top of MapReduce. That is, on the when we create a Pig script or Hive script to retrieve the data, on the back end, again the MapReduce will be run. That is, suppose before we have like what you say telephones. Now we have mobile phones. Like that, the first generation is MapReduce. The second generation is Pig and Hive. Suppose if you want to write a program using MapReduce, it will take Java. You have to use Java and it will take almost 10 to 15 lines. If you write the same program using Pig or Hive, it will take only 5 lines. So the same data can be analyzed using MapReduce as well as Pig and Hive. Now the third generation is also came, that is Spark. Okay.
What is the third generation?
Spark.
Spark.
S-P-A-R-K.
S-P-A-R-K. Spark. Okay.
Yeah. So there are 5 services required to run Hadoop. Okay. First one is name node. Next one is data node. Next one is job tracker. Next one is task tracker, and next one is secondary name node. So these are the 5 services. These are the services. If these 5 services are available, then we can say that the Hadoop is running in your system or a cluster. That I'll explain in coming slides. So what do you mean by name node? What do you mean by data node? What do you mean by job tracker, task tracker, and secondary name node? This concept I will be explaining in coming slides. So now we'll see what is mean by Hadoop and how the name Hadoop is been came. So basically, the Dow Cutting has introduced this Hadoop concept. So how he has given the name Hadoop is because his son is playing with a toy elephant, and he has given the name as Hadoop to that toy elephant. So based on this, he has given the name as Hadoop to this framework, and he has given the symbol of toy elephant. There is no other intimation or no other reason for giving the name of Hadoop to this framework. Okay. Next, in 2002, Dow Cutting created an open source web crawler project. Open source web project. Just created a project. In 2004, Google published MapReduce and Google file system papers. Only papers. In papers, they have wrote that this is the MapReduce. This is a Google file system. In 2006, Dow Cutting created an open source project and Hadoop file system project. And in 2008, they created a 4,000 nodes. Means 4,000 node cluster means with 4,000 systems, they have created a cluster and they stored the data, that is of terabytes of data, and they tried to retrieve the terabytes of data, and they became a successful. They won terabytes of benchmark. And in 2009, the Facebook provider SQL. We can also use SQL in Hadoop. SQL support to Hadoop. Okay. So actually this Hadoop is introduced by Dow Cutting, who is working in Yahoo. Then he donated this software to Apache Foundation. So if you go to Apache website, we can easily obtain or we can easily get this Hadoop software. So a lot of companies are using Hadoop. The mainly companies which are using this Hadoop are almost huge companies are using. These are the companies which are started using from last 6 to 7 years. Cloudera, EMC, Mapper, Hortonworks, Amazon, Facebook, eBay, Twitter, Google. These are some companies. They are huge companies which are using Apache Hadoop. So Apache Hadoop is a basic version. Okay. Now for the basic version, there is no support is provided. That is, suppose a Hadoop is there, we have to the different components like MapReduce, Hive, pick everything we have to install. So we have to go to Apache website and we have to download. So for that, a support is provided to Hadoop, and there will be, if you download that, we can we don't need to install anything. Directly we can develop like scripts. That is what to say is, suppose if in Apache Hadoop we have different modules like Hive and Pig, everything we have to install manually. But the Apache Hadoop has been taken like Cloudera, and they have created their own cluster where they will install everything. Just as a developer, we want to work or we have to create a scripts on it. There is no need to installation purpose. That is admin, as a admin, the admin purpose is to install and the developer purpose is to write the script. So as a admin, he don't need to install because Cloudera will perform the admin work and he will be creating a system, and as a developer you have to work on these scripts. That is what to say is, in basic Apache Hadoop, everything we have to do manually, installation, and after installation the writing the script. But in the same Apache Hadoop has been taken by Cloudera and Mapr. They will look after the installation part. As a developer, we have to work on that installed system. Like we have to just create a script and process the data. Are you getting?
Yes, yes, I'm getting.
Yeah. So, but
So,
basically, if you work, yeah, tell me.
yeah, you are telling about developing part, right?
No, no,
That
like
one.
just
So,
just installation means first we have to install like Hive, Pig, Scoop, HPace. After installation, we will be creating the scripts like Hive, Pig, Scoop, like suppose MapReduce is there, Hadoop is there. Hadoop consists of MapReduce, Hive, and Pig. All these are modules. First we have to install. This installation part is related to Hadoop admin. Okay. Then after installation, if yes, now I'll open a Pig, and if you write any Pig script, that is a development part. Okay. So in if you go to Apache Hadoop, admin part and development part, we have to work by both. Okay. We have to do by ourselves. Whereas in Hadoop, if you go for Cloudera or Mapr, the admin part is done by them. Just that is the installation is everything will be done by them. Just we have to write a scripts. So just I'm giving you the idea about development also. Just starting. Just I'm telling that this is what the concept. So admin means you have to know the knowledge about what are the different companies which provide Hadoop. So Hadoop is provided by Apache. That's I mean to say here is the Hadoop software is provided by Apache Hadoop as well as Cloudera, Mapr, and Hortonworks. So there are different versions. Like you can say like we have different operating systems like Windows, Linux, Ubuntu, right? Like Ubuntu,
okay.
Windows, like that. The Hadoop is also having different versions like Apache Hadoop, Cloudera Hadoop, Mapr Hadoop, Hortonworks Hadoop. In real time, they'll be using Cloudera or Hortonworks. Someone will be using Apache. That's what I mean to tell you. Are you getting?
Cloudera and Mapper?
Cloudera, Mapr, Hortonworks.
Okay, okay.
In our company, they are using Hortonworks. In some
Okay,
companies, they will be using Cloudera. In some companies, in Apache, there is a flavor known as vanilla. They will be using Apache vanilla flavor. Depending upon the requirement, they will be using. So you should have a basic idea on development also. So what in real time is, as a Hadoop developer, he will create a scripts to process the data. He will issue a ticket to the Hadoop tester. Then the Hadoop tester will check the scripts created by the developer. Then he will send the scripts after checking to Hadoop admin, and Hadoop admin will run the scripts, and if any failure occurs, he will raise a ticket to developer. Okay.
okay, fine.
So this is a
So,
basic.
okay,
Yeah.
yeah, tell me.
Okay. This is a basic cluster architecture. You can see these are 6 blocks. We can say it as a 6 nodes or a 6 systems or a 6 servers. We can say it as a 6 node cluster. So we have different services here. First one is name node. Next one is SNN stands for secondary name node. JT stands for job tracker. DN stands for data node, and TT stands for task tracker. So what
Okay,
is use of a name node? Okay, the name node will store the metadata details. Suppose I want to store a sample.csv file into the Hadoop cluster. So in which location I have to be stored, that will be explained by the name node. That is, the name node will be holding the metadata details. So the data nodes will be holding the data. Suppose, so inside the data nodes will be having the blocks B1, B2, B3. Suppose a file is there. If we store the file into the data node, it will be divided into blocks. Each block size is by default 64 MB. Suppose a file you are storing is of 256 MB. If you try to store it into the data node, it will be divided into 4 blocks of 64 MB. 64, 64, 64, 64. Are you getting?
yes, yes, yes.
So suppose I have 3 data nodes. So in every data node will be having a blocks concept, but the data node 1 and data node 2 are full. The data node 3 is empty. So the name node will say that the sample.csv want to be stored in the Hadoop cluster. So the name node will tell that I have an empty location in the data node 3 at block 1 location. You can store the file in this location. So the name node will be having the metadata details. So suppose a file sample.csv I have stored in the data node 3 at block 1 location. That address will be available in the name node. Okay, this will be saying as a metadata. So the name node will be holding the metadata details. So the metadata details in the name node will be calling as fs image. Okay.
Yes, yes.
F for friend, S for system, image, fs image.
Okay. Okay, okay.
And same metadata in a compressed format, it will be stored in a secondary name node. That will be calling it as edit log, editlog.
Okay.
So because the same metadata will be having a one more copy, because if name node fails, we need that metadata information. So in order to have the replica copy, we will be using secondary name node. So if one system fails, the data, suppose if the name node fails, we don't know the locations of the files in different data nodes. So we'll be having a one more copy, so that if name node fails, we can access the data from the secondary name node. Okay.
Okay.
So next one is job tracker. The job tracker will receive the orders from the name node and will assign the task to the task tracker. So for each data node, there will be one task tracker. Job tracker main responsibilities is it will receive the tasks from the name node and it will assign the task to the task tracker and it will schedule the jobs. Okay.
Can you tell me once again about
Job tracker will receive the orders from the name node, what are the tasks to be performed. Okay, first one.
Okay, okay, okay.
And it will assign the task to the task tracker of each data node. Okay.
Okay.
And next one is it will schedule the jobs. Means this job has to be run at this time, this job has to be run at this time. It will be scheduling the jobs. Okay.
Okay, okay. So it acts as a mediator. It acts as a mediator between the node name and task tracker, right?
Name node and data node. Inside the data node only task tracker will be there. For every data node, there will be one task tracker will be present. Okay.
Okay, okay.
So this is about job tracker. Next, data node. What do you mean by data node? So data node is like a system where we can store the data. So suppose a sample.csv is there. So sample.csv we want to store into this 6-node Hadoop cluster. The sample.csv will be contacting the name node and name node will be providing the empty locations in which of the data nodes. In that particular data nodes, that file will be stored in the form of blocks. Okay.
So
inside
is it going to write simultaneously? Like you said, there are six data nodes. Okay. So how it is going to write? If, for example, the data is like ABCDFG. So is it going to write? Is it going to write A in the first node, B is going to in the second node, C is going to write in the third node, or like that, or ABCDF in the first node itself?
So I said that if the file is of 128 MB, first 64 MB, first it will be stored into the one block, next 64 MB in one block. So if the file, consider the input file is 128 MB, okay?
Okay, okay.
So the first 64 MB means first half maybe. The first half will be stored in one block, next half in one block. If the file is of only less than 64 MB, everything will be stored at a time in one block, okay?
Okay.
Because we will be setting a configuration file that whatever the input file, if the input file is of like, suppose like 256 MB, I want to store in the Hadoop in only 64 MB. So it will divide it into 464 MBs and it will access 1164 MB into one block simultaneously.
Okay. For example,
at the time,
you said like 64 MB, right? The block size is.
Yeah.
If the file size is around like 40 or 50 MB, what about the remaining space? Is it going to waste like that?
No, remaining space. No, it will be stored into this block, and remaining space can be used for other nodes, other data.
Okay.
Because we will be having the end of line delimiter like dot or empty space, means it will be indicated that that is the end of that particular data information. Next, it will be start from next line. Okay.
Okay.
So suppose a file is there, because there will be an end termination after the file is two lines are there. After that line there won't be next line, that is a dot or end of line termination will be there, like delimiter will be there, end termination
Okay.
delimiter like dot or comma. So it will be understanding
Okay.
that this is up to which the data is there, remaining is not there. Okay.
Okay.
So next one, inside the data node we'll be having a task tracker. For every data node we'll be having a task tracker. Okay.
Okay.
Task tracker is mainly used to perform the tasks of a job tracker. What is the use of task tracker and all we will be coming to know in next slides. So all these 6 systems will be combined or connect. Each system we can say is as a server or a system. We can say it as a node or server or a system. All these 6 will be connected through a wires. Okay.
Okay.
And they will be forming a 6 node cluster. Okay.
Mm-hmm.
So name node will hold the metadata details. The metadata details will be calling it as a FS image.
Okay.
The same metadata details will be present in the secondary name node. That will be saying it as a edit log. Job tracker will schedule the jobs, and what are the jobs which are scheduled by the job tracker will be performed by the task tracker. The data nodes will be storing the data in the form of blocks. Okay.
Okay. Okay.
So this is about the basic architecture. The 5 services are name node, secondary name node, data node, job tracker, and task tracker. If these services are started, then only Hadoop cluster is started. Okay.
Okay.
So what is this rack awareness? So this is a 6 node cluster. So these clusters we can't see in here. We can see only in the data sensors, they are present in USA. So these clusters, to prevent from the damage, they will be enclosed in some rack. So all these 6 systems will be enclosed in a rack to prevent it from a damage. Okay.
Mm-hmm.
This we can say it as a rack awareness. So like some rack will be there, inside the rack all the 6 systems connected, it will be placed inside the rack so that it will be prevented from damage from the external environment. Okay.
Okay.
So by default the block size in Apache Hadoop is 64 MB. I said you that the Hadoop has different flavors like Apache, Cloudera, Hortonworks. In Apache Hadoop they set the block size as 64 MB, whereas in Cloudera they have set a block size as 128 MB. Okay.
Okay. 128. Okay.
So suppose a file is of 256 MB, it will be divided into 4 blocks in Apache Hadoop, whereas it will be divided into 2 blocks in Cloudera. Okay.
Okay.
So configuration files, these all under very important as we are going for admin purpose. So what are the different configuration files available? So hdfs-site.xml, core-site.xml, mapreduce-site.xml, masters and slaves. These are the different XML files available. First we will go for core-site.xml. The core-site.xml will have name node IP address. Suppose a system is there. If we load this XML file into that particular system, the system will be acting as a name node. That particular name node IP address will be writing in this XML file and will be configuring this file in the configuration file. Okay. After installing the Hadoop, there will be some configuration files. If we load this configuration file into particular system, the system will be acting as a name node. Okay. We have to remember that core. Yeah.
Oh, one second. Can you get back? If you don't mind.
So the core-site.xml will have a IP address of a name node. That is, these are the 6 systems, right? This system IP address will be stored in that XML file. Okay.
Okay.
So then this XML file indicates that what is a name node. If it's a 6 node cluster, if you open this XML file, we will be understanding that okay, this is the name node. Okay. If it will be having some IP address. So that IP address indicates that okay, this system is name node. We'll be getting to know. Okay.
Okay.
So 6 systems, we want to know which is the name node. How we can know? Using this XML file, we can know that okay, that XML file will have the IP address. So depending upon the IP address, we can know that okay, this is the name node. Okay.
Okay.
So mapreduce-site.xml will have the IP address of a job tracker. Okay.
Okay.
Masters will have the IP address of secondary name node.
Okay.
And slaves will have the IP address of all the data nodes. If there are 3 data nodes, it will have IP address of 3 data nodes. If there are 4
What
data nodes, it will have a
Yeah, tell me.
So the slaves XML file we have a IP address of the data nodes. If there are 3 data nodes, all the 3 data nodes IP address will be having in this slave. So the three systems will act as a data nodes. Okay.
What about HDF underscore
Yeah.
site.xml?
So HDFS-site.xml have many properties, but the main properties which will be taking into consideration is block size, okay, replica, heartbeat, and trash. First one will be going for trash. Suppose I have set a trash interval as some 60 seconds. Suppose if you delete a file from a Hadoop cluster, it will be present in recycle bin for 60 seconds. After 60 seconds, it will be permanent delete. That is, during the 60 seconds, if you try to retrieve the data, you can go to recycle bin, and if you type restore, you can retrieve. Okay. If you set a trash interval as 0, if you delete a file from a Hadoop cluster, it will be a permanent delete.
Okay.
Are you getting?
Yes, I got it.
So this is a trash. Next one is block size. We are saying that in Apache Hadoop, the block size is 64 MB, 64 MB, 64 MB. Where we'll be setting in this XML file, we'll be setting it as 64 MB. That's why whatever a file, when it enters into Hadoop cluster, it will be divided into 64 MB blocks. If you set here as 128 MB or 256 MB, when it enters into the Hadoop block cluster, it will be divided into 256 MB blocks. Okay. As here we set as a 64 MB, it will be divided into only 64 MB. Are you getting?
Okay. Yes, yes, yes.
And next one is, now we have seen about trash and blocks. Next one is replica. Suppose if we store a file sample.csv into the Hadoop cluster, it will be having a 3 copies. It will be replicated 2 more times. So we'll be having a 3 copies here in Apache in Hadoop cluster, because the same file will be stored in 3 different systems. Because if even one system fails, we'll have the data in 2 more systems also. Okay.
Okay.
So by default, we'll be setting a replica as 3. Whatever the file we store in a Hadoop, it will be having a 3 copies. So we'll be having more safety and more reliability. If one system fails also, the same data will be available in another 2 systems.
Okay.
So the 3 properties we learned is trash, block size, and replica. And the fourth one is heartbeat. What does mean by heartbeat? Heartbeat signal. So every data node will send a signal to the name node for 3 seconds. So
Okay.
if it won't send a signal to the name node, the name node will assume that the data node is not working or there is some damage in the data node. So the signal sent by the data node to the name node for every 3 seconds is known as a heartbeat signal. So if data node won't keep the won't send a signal to the name node, what it will do is the Hadoop admin will keep the cluster in the safe mode, because what Hadoop admin will come to know that the data node didn't send a signal to the name node for 3rd second. Then that is means that the data node is not working, or the data node is failed, or there is some repair in the data node. So the Hadoop admin will keep the cluster in the safe mode, and it will try to make the modifications in the data node which has been repaired or which has been failed, or he will try to replace that data node with new data node, so that to prevent that, to make that particular changes, he will keep the cluster in the safe mode. When he keep the cluster in the safe mode, as a Hadoop developers can't access this cluster. That is, if the cluster is kept in the safe mode by Hadoop admin, during this time, Hadoop developers can't access the data from the Hadoop cluster, and also can't store the data from the Hadoop cluster, can't retrieve the data from the Hadoop cluster. That is, if the system is in the safe mode, Hadoop developers can't write the data into the cluster and can't read the data from the cluster. Means Hadoop admin, if keep the cluster in the safe mode, it means that he's making some modifications to the cluster. Okay.
Okay.
Then after making the modifications, he will release the safe mode. Then after, developer can access the data. Okay.
Okay. If you said there are 3 nodes, right? So one of the node is meant to fail, like a data node, regarding data node.
Yeah.
So the customer can't write anything.
One of the data node fails. If there is any fault in a cluster, what he will do is, the Hadoop admin won't give the developer to write the data into the cluster. He will keep the cluster in the safe mode and he will repair. After the repairing, he will release the safe mode. Then after only developer can access the cluster. Okay.
Okay. Okay. So it will be it will be like an outage, right, for the customers.
It will be like a
outage.
Yeah. So
Down, down,
any, yeah, it will be
downtime.
like if any, so it will be like the cluster will be like it will be in a safe mode, means it can't be accessed because he'll be in a repair mode. It's like a temporary off mode. That is, he will be
Okay.
making some modifications so that no one can access that cluster, because there's a damage there. There's a damage. You have to make some repair to this cluster. Okay.
Okay.
So once the
So
repair is done, he will admin will come will release the safe mode. He will have the safe mode so that all the developers can access the data.
okay.
Are you getting?
Yes, I got it.
So okay, these are the different
Yeah,
configuration files.
yeah, you said that FTS under site.xml file. The
Yeah.
next one.
Yeah.
No.
So
Yes.
yeah.
So, is it possible to edit the things in the XML file? Because you said
We can
uh,
in Hadoop, after installing there will be a folder known as config folder. Inside the conf
mhm,
folder we'll be having these XML files. There we can edit. We can set a
yeah,
replica as 4, we can set a block size as 128 MB, we can set a trash interval, we can set the heartbeat signal. So heartbeat signal is a signal sent by the data node to the name node for every 3 seconds. If you want, we can make it as a 10 seconds. By default they have kept these as their default values. If you want, you can change
yeah.
these values. Okay.
You said like 64 MB in the block size. We can change it,
Yeah.
right?
Yeah, you can
Okay.
change.
Okay.
So you know that the Cloudera had made it to 128 MB.
Yes.
So what are the different types of operations we'll have there in HDFS? First one is HDFS write, next one is HDFS read, and next one is HDFS delete. Okay. What do you mean by HDFS read? Suppose I want to store a sample.csv into the Hadoop cluster. Okay. The client will contact the name node. Okay. The name node will provide the metadata details. That is the empty locations available in particular data nodes. There are 3 data nodes. In which data node there is an empty location. Okay. That details will be provided by the name node. Okay. To the client. Then using the data streamer, there will be internally concept known as data streaming inside the Hadoop. Using the data streaming concept, the file will be loaded into the data node. Okay.
Okay. What do you mean by HDFC? HDFS?
What? HDFS is
HDFS.
Hadoop distributed file system. I say that Hadoop consists of 2 modes, data
Okay.
storage and data analysis. For data storage, we'll be using Hadoop distributed file system. For data
Okay.
analysis, we'll be using MapReduce, Hive, and Peak, and
And
Spark.
yes.
So if you
Yes.
want to write a file or data storage, this is about the data storage. If you want to store the data into the Hadoop cluster, the client will contact the name node, and the name node will provide the empty locations, that is metadata details of the data node. Using the internal concept known as data streaming, the file will be stored into the one data node. Okay. But by default, we should have a replica of 3 in Hadoop. So we should have 2 more copies. Okay. For
Okay.
that, we will be using a concept of pipeline dating. Using the concept of pipeline dating, we can have 2 more replica copies in another 2 data nodes. Okay.
Okay. Is data is going to replicate from uh, uh, data node or name node?
So no, from name node will have only metadata details, that address locations. Data nodes will be
No.
having the data.
Yeah. What you said is right. So if the customer wants to write a particular data, it is going to contact the name node. The name node is going to tell the
address locations.
Address location of the data node 1. Okay. Now the customer writes the data through name node to the data node 1. Okay. Once he writes in the data node 1, the customer is going to get the acknowledgement directly from data node 1. Yes. Once he writes the data into the data node 2, data node 3, once the activity completed, then only he is going to get the acknowledgement.
After writing into the 3 data nodes only, he will getting the acknowledgement. Using the data streamer, it will be stored into the first data node. There will be like between the data nodes, there will be a connection, like it will be interlink using pipeline dating. The same copy will be replicated into 2 more data nodes. So after the data is stored into different 3 data nodes, that particular data location in different data nodes will be available in the name node. Once it is done, the acknowledgement is sent to the client.
Great, 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 great.
So this is about HDFS, right? During the HDFS, right, the services we are using it only the name node and the data node. We are not using here secondary name node, job tracker and task tracker. Okay.
Okay.
So next one is HDFS read. So whatever the data we stored, if you want to retrieve the data, the client will contact the name node. Okay. The name node will provide the metadata details to the job tracker. What the job tracker will do, the job track, the client will say to the name node that I want to retrieve the sample.csv from the Hadoop cluster. So the name node will send that request to the job tracker. So job tracker will read the address locations or metadata details from the name node, and it will assign the task to the task tracker of particular data node. Suppose that sample.csv is present in the data node 1, then the job tracker, it will assign the task to the task tracker of data node 1, and he will try to create some logic that may be like a hive or pick or map reduce logic, and he try to retrieve the data. Okay, this is about HDFS read. Are you getting?
Yes, yes, yes.
So here we'll be using name node, data node, job tracker, task tracker. All we are using.
Okay.
Next one is HDFS delete. Suppose a client want to delete a file which is stored into the Hadoop cluster. The client will contact the name node, and the name node will assign the task to the job tracker. So job tracker will get the file 3 locations. It will be stored in the 3 data nodes. Like all the addresses, it will take to the checks from the name node, and it will assign the task to the task tracker of all the 3 data nodes to delete that particular file, and the task tracker of each data node will create a logic internally, and it will delete all the 3 files. Okay.
Oh, 1 second, 1 second. Then
So if you suppose the file which is stored in the Hadoop cluster, I want to delete that file. So the client will contact the name node. Okay.
okay.
So the name node will assign the task to the task tracker. What we will do, the task tracker will read the address location. Suppose a sample.csv is stored in the data node 1, and that is replicated into the remaining 2 data nodes also. Okay.
Okay.
So then the job tracker will take the address location of the the 3 data nodes from the name node, and it will assign that particular task to the task tracker of all the 3 data nodes. And the task tracker will try to delete the file from the data nodes.
Okay. Okay.
This is about HDFS delete. Okay, are you getting?
Yes, yes.
So next we'll go for heartbeat signal. What is mean by heartbeat signal? For every 3 seconds, the data node will send a signal to the name node. Okay. So that if data node won't send a signal to the name node will assume that there is some problem in data node, or the data node is failed. Okay, this is known as heartbeat signal.
Oh, who is going to send the signal? Data node or node name?
No, data node will be sending a signal to the name node. Okay, that is signal will be saying it is a heartbeat signal. For every 3 seconds, the data node will send the signal to the name node.
Okay.
If the signal, if there is what to say, if it won't send a signal to the name node for every 3 seconds, then the name node will assume that the data node is failed, or there is some fault in the data node. So he will keep the cluster in the safe mode. Okay.
Okay.
Are you getting?
Yes, yes, yes.
So this is known as heartbeat signal. So for every 3 seconds a signal is sent. This is a heartbeat signal. So every 10th heartbeat signal, that is 30 seconds. One heartbeat signal is equal to 3 seconds. So every 10th heartbeat signal, that is for every 30 seconds, a block level report is generated.
Every?
Are you getting? Every 10th heartbeat, that is 10 into 3. For every 30 seconds, a heartbeat signal is generated.
Okay, okay.
What do you mean by
every 3 seconds? That you. Okay.
Yeah, for every 3 seconds, a heartbeat signal is sent by the data node to the name node. That is heartbeat signal. Okay.
Okay.
10th heartbeat, that is 10 into 3. For every 30 seconds, a block level report is generated. Okay.
Okay, okay.
That is for 10th heartbeat. That is for every 30 seconds.
Okay, okay.
Block level report is generated. What is this block level report? The block level report is a repeated check of metadata information in the name node. So that is for every 30 seconds. Suppose 10 files are stored in the data node. So what are that locations in the data node? Like the sample.csv is stored in the data node at block 1 location. that address location is compared with the metadata details like address location is in the name node. Are you getting? Because
Yes, yes.
to, to know that the address locations in name node are correct or not. Suppose the file sample.csv is present in the data node 1 in block 1. So we have to see that whether the name node is also having the same address locations or different address locations. Okay.
Okay.
You should also have the same address location. Then only if the client want to access this cluster, it can show the right path. Okay.
Okay.
So for every 10th heartbeat signal, a block level report is generated. A block level report is a repeated check of metadata details of name. Okay.
Okay.
So this is about a block level report. And next we'll have two types of transactions, OLTP and OLAP. OLTP is nothing but online transactions. OLAP is known as analytical data, online analytical data. So Hadoop is mainly used to store analytical data like historical data like Charminar. What do you mean by like a place, historical place like Taj Mahal? If the data is there, if you want to store that analytical data. Transactional data means what are the data related to money like online transactions like Flipkart, Snapdeal. So for OLAP we will be using MapReduce -pig. For OLTP we will be using Spark. Okay.
No, I didn't get you this point. OLTP and OLTP.
So in data is classified into two types: analytical data and transactional data. Analytical data is a data that won't have any transactions. Transactional data is a data related to money transactions. Like if you buy anything in a Snapdeal, you'll be paying money. Like there'll be transactions. If you make some if you buy some, or if you make some many bank transactions, debit or credits, okay, that are online transactions.
Okay.
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 So that data, like if you make any recharge, that is online recharge, that is an online transaction, right? You will be using a money here.
Okay.
Okay. So if you want
Yeah.
to store that data, we'll be using a Spark framework. Okay.
Okay.
The transactions related to money, if you want to store, we'll be using Spark. Like another transaction, like if there is no transaction, there is no we have a data, but that is not related to money. Like Taj Mahal is there, that is historical data. Okay. Next after
Okay.
Taj Mahal, like something like you can say like Charminar. Everything is a data. We will be wiki. What is where it is an origin? Who is an author? How it came into the existence? What is the famous things about it? That is the historical data. Okay.
Okay. That is called
That is an
analytical data.
analytical data. So for
Okay.
Hadoop is mainly used to store analytical data.
Okay.
So nowadays they are trying to store transactional data also. For transactional data they are using Spark. Okay.
Okay. What
So
about for OLAP?
mainly
OLAP?
OLAP is mainly for high pig map reduce, everything is there. Right?
Okay. Okay.
So the pig can process structured, unstructured and semi-structured data. MapReduce also can process structured, unstructured and semi-structured data. Hive is similar to RDBMS like MySQL and Oracle. It can process only structured data. Okay.
Okay.
Whereas Spark can process structured, semi-structured and unstructured.
Okay.
So next there are three types of replica: missing replica, over replica and under replica. Okay. So are you getting?
So between the data nodes.
No, replica. What is this replica concepts? I'll tell you. Missing replica, over replica, and under replica. Okay.
Okay.
What you can see my screen, right?
Mm-hmm.
You can see my screen, right?
Yes. Yes. Yes.
So suppose a file I store into the data node, it will be stored into three different data nodes. A
Right.
sample.csv, if I store into the data node 1, the same is replicated into two more data nodes. Now we have a replica of 3.
Right.
Okay.
See. Right. Right.
So suppose after some time this data node stops sending a heartbeat signal to the name node. Okay.
Okay.
Then the name node will assume that this data node is failed.
Okay.
So now we have only two copies in two data nodes because this data node is failed.
Okay.
By default we should have a replica of 3, but we have a replica of 2 only now. This is known as under replica.
Okay.
So what I will do, Hadoop admin will keep the cluster in the same safe mode, and you will add one more data node to the cluster, and you will copy the file into that data node. Okay.
Okay. Okay.
So now we have normal replica. What happens after some time, the failed data node will start working, and it will also send the heartbeat signal to the name node. Now it will have a
Okay.
4 copies. Okay.
Okay. Mm-hmm.
So by default we should have a 3 replica, but we have one more extra replica because we have 4
Okay.
data nodes and 4 copies. This is known as
Okay.
over replica.
Mm-hmm.
So we have known about under replica and over replica. Have you
Okay.
got right?
Yes, yes, I got it. Point.
Next one is missing replica. So this is like a cluster mode. Whereas if you use in a laptop, the name node will be in a single system, data node will be in a single system, secondary name node will be in a single system, all the 3 data nodes will be in a single system. Job tracker will be also in a single system. That will be saying it as a pseudo node. Means in real time we'll be using a cluster mode, whereas for practice we'll be using a pseudo, means single node. All the services will be running in a single node. Okay.
Okay.
So, but here we can maintain only, suppose if you want to store a sample.csv, we can have a single file only. We can, because we here all the services are running in a single system or single laptop. That is, we are having only single node. So we here we can't maintain a replica of 3 copies. So he can have a replica of 1 copy, and the 2 copies of replica is missing. That will be saying it as a missing replica. Are you getting?
Yes, yes.
Because the laptop will be installing Hadoop in a laptop and will be working. All the services will be installed in a single system. Like whereas in real time we will be installing in a separate system, but in a laptop for a practice we will be installing everything in a single system. That will say it as a pseudo node. So the data node, all the 3 data nodes will be in, all these laptop will work as a data node 1, data node 2, data node 3 as a secondary name node and job tracker. So here we can maintain only 1 replica because we are having only 1 system. We can maintain only 1 replica, and the 2 more replica is not available here. Means we can't maintain 2 more copies. Okay, even if
Yes.
you maintain
Yes.
2 more copies in this system, if this system fails, all the 3 copies will be filled. That's why here only 1 replica will be maintaining. As we don't have 2 more data nodes, we can say it's just missing replicas 2. Are you getting?
Yes, yes, yes.
This is about missing replica, over replica, under replica, and missing replica. Okay.
Okay.
Next, scaling. There are 2 types of scaling: horizontal scaling and vertical scaling. So what is this scaling? You have any idea about scaling?
No, 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 no. Really.
So suppose all the 3 data nodes, I will say that this RAM is 1 TB and hard disk is 1 TB. This data node RAM is 1 TB and hard disk is 1 TB. This data node RAM is 1 TB and hard disk is 1 TB. So all the 3 data nodes are full with data. Okay.
Okay.
It is full. I want to add some more data. All the
Okay.
3 are full. So how can I add? So if I increase the RAM and hard disk of existing data node to add the data to the Hadoop cluster, that will say it as a vertical scale.
Okay.
So instead of increasing the hard disk and RAM of existing data node, if we add one more data node to the cluster, we will be saying it as a horizontal scaling. Okay.
No. Vertical scaling, horizontal scaling. Can you tell me once again, if you don't mind?
So okay, instead if we increase the RAM and hard disk of existing data node to add the data, we will be saying it as a vertical scaling. Okay.
Okay. Okay.
Instead of increasing the RAM and hard disk of existing data node, I will add one more data node to the cluster of 1 TB RAM
Fourth
and 1
node.
TB hard disk. Okay.
Fourth node. Right. Okay.
That is known as horizontal scaling. After adding,
Okay.
when I am adding the one more data node, I will keep the cluster in the safe mode, and I will try to distribute the data of these data nodes to this newly added data node so that the data is shared equally among 4 data nodes. This is known as load balancing. Okay.
Okay. Okay. I got it.
After after adding the new data node, we will be taking some data from the 3 data nodes and we will be storing it into the 4th data node. Then after we will be removing the cluster from the safe mode. Then after whatever the newly coming data we can store into this data nodes. Okay.
This one takes a lot of time, right? Because the data needs to be retried from 3 nodes to the 4th node.
Yeah. So
Yeah.
so generally before we have a project. So we will be, depending upon the project requirement, we will design a cluster. Suppose we will be daily 1 GB is coming. So like the project is for 6 months. So depending
Okay.
upon the requirement, we will design a cluster. Okay. Suppose instead of 1 GB, if 2 GB is coming, at that time this phenomena will occur. We try to add one more data. Okay.
Oh, one more data node. data node?
One
Or
more data node to the cluster.
okay,
Cluster.
okay. Okay.
In real time, we'll be using horizontal scaling, then vertical scaling.
Which one you prefer, like vertical scaling is better or horizontal scaling is better?
Horizontal scaling. Suppose we'll be
Horizontal.
designing the cluster depending upon our requirement. Suppose the client will say that I'll be sending you daily 1 GB data, okay,
Mm-hmm.
for
Mm-hmm.
30 days. So that is I'll be
Okay.
sending you 30 GB. Means I'll
Okay.
design a data node up to 40 GB. Means with extra 10 GB, not 30 GB means with replica it is 90 GB. Okay.
Okay. Okay.
So I'll be keeping a 100 GB cluster, okay, with
Okay.
some extra
Okay.
space also. Suppose
Okay.
instead of 1 GB, if we start sending 2 GB daily,
Okay.
it is 60 GB. With replica, it is 180 GB.
Okay.
Then at that time, we have to do these modifications.
Okay.
So first, we'll be
So
depending upon the data coming, we'll be designing a cluster.
okay. So yeah, you said like we take precautions and build the structure. Like if we go for 100 GB, later we got overload and the spaces we need to increase. If we go for horizontal scaling, we need like a downtime. Like you need to you said that admin is going to take into the no safe mode,
Yeah.
and then he's going to add the fourth node or fifth node or sixth node, and later the data is going to split in all the six nodes, and he'll remove the safe mode. So that in this meantime, it will take a lot of time. So this is going this time is going to affect the customer, right?
Yeah.
So instead of this one, if we go for vertical scaling, we can increase the disk space in all of the nodes and all of the three nodes. Then at that time, it is not necessary to keep it in the no safe mode, right? So there will be no impact.
Even for vertical scaling also, we are making some modification to cluster, right? It will be kept in the safe mode only. So when is this situation happens? So if before the project starts, everything will be taken into the consideration. He will allocate some efficient space. So what the client will be saying that daily I will be getting only 1 GB of data. So depending upon the input specifications only, the Hadoop admin will design the cluster. 90% of the time this problem won't occur. In some rare situations this problem occurs. At this time the Hadoop admin will keep the cluster in safe mode and he will add one more data node or he will make the modification to the existing data node.
Okay, fine, great.
So he can use vertical scaling or horizontal scaling, but in real time more horizontal scaling will be used. Okay.
Okay, fine, yeah.
So this is about some basic demo. Okay. Tomorrow we can continue remaining part.
Okay. Yeah. Karthik. Where are you from, Karthik?
What?
Where are you from?
I'm from Bangalore.
Bangalore. Yeah. Thanks, Karthik. Yeah. It is quite interesting topic, and it's easy for me too because I have a lot of admin knowledge. So that's why I'm questioning you each and everything. Don't matter. Okay.
No problem. No problem. If you interact more, so you will get more subject.
Yeah, each and every day I want to prepare on this one, so I don't want to waste anything. I don't want to waste my time. So let me know how I need to prepare also this one. Each and every day.
I'll be once the course is completed, I'll be sending you the Viva questions also. Whatever the topics I'm telling you, just write some notes after class is completed. Whatever the knowledge or whatever the things you got into your mind, just write it. Okay, so that it will be easy. Whatever the PDFs or PPTs I am giving, you can't get that much enough knowledge. Whatever you listen, if you write it, that will be useful for longer time.
Okay, fine, sure.
So tomorrow, which time do you need? Morning or evening? Morning.
Yeah, it's up to you, Karthik.
So morning 7 a.m. you will be available?
Morning 7 a.m. in your IST, right?
Yeah, Indian. You are from India only, right?
No, I am in US. Right, I'm in Texas, Central Time.
Yeah, okay. So then so morning 8 a.m. 8 a.m.
Morning 8 a.m. means my time is 9:30. Okay, no problem at all. I'll be.
Morning 8 a.m. IST.
Okay, fine, no issue.
So I'll
Can join.
I'll be sending you the course content to you. Okay.
Okay.
So tomorrow we'll be meeting at 8 a.m. Sure. Okay.
Sure, Karthik.
Okay. Have a great day.
Thank you, Karthik. Thank you.
Thank you.
Yeah. Bye.
Bye-bye.